Hello, hello, this is Mr. Barr, and this is one non-infinite but by inspection. In the last lesson we graphed it. This time we're not going to be graphing it, we're just going to be looking at the equations. So my goal, I can use linear systems to solve real-life problems. My why, line equations will help me understand the world around me and make predictions. We are the kings and queens of graphing. We can graph lines and determine if there is one, none, or infinite solutions. But is there a way to determine the number of solutions without graphing? What do you think? And hopefully you're thinking, yes, there is a way. But let's do a quick review of how to do this by graphing. Okay, so quick review. Graph a line, one solution. Graph a line, no solutions. Graph a line, infinite solutions. But I don't want to do that. I just want to look at the equations and figure out what's going on. And that's what we're about to do. So let's get our notes ready to go, which will be one none infinite by inspection. Start with your name. One none infinite by inspection. Inspection meaning just by looking at it. So we have the slope-intercept equation here. We have y equals mx plus b, and we know that the slope is m and b is the y-intercept. And if I have those two things, I can tell if lines are going to cross, be the same line, or if they're going to be parallel. So as long as I have y equals mx plus b, I've got everything I need. So I have my slope, my move, my rise, run, my y-intercept, my b. So when I look at these two guys, I could graph them, but I don't want to graph it. Because right away, I can see that they have the same slope, but different y-intercepts. Same slope, but different intercepts, which tells me there will be, let's see, this one starts at 3, goes up 2 over 1. Starts at -2. They're parallel lines, which means they're not going to cross. But I could see that right here. Just by looking at this, I can see that they have I can see that I can't draw. They have the same slope, but they have different intercepts, which tells me there's no solution. If I come down to this one, I can look at them and I see, hey, they're the exact same line, which means there'll be infinite solutions. It's the exact same line, infinite solutions. Same slope, same intercept. Infinite solutions. Here, I'll graph this one. But I can see right away there's going to be one solution. And here's how I can see it. Start at 4, go up 1 over 1. Here, start at -2, go down 1 over 2. Are they going to cross? Yes, they're going to cross right here. But I didn't have to do that. If I look at the slope here, and I look at the slope there, I can see that the slopes are different. Different slopes means they're going to cross, which means there's going to be one solution. We'll get this into our notes in just a moment, one solution. All right, so back to our notes. So I'm thinking here. This game only works in slope-intercept form. So if you're given a standard form, you need to start by doing a move the x, divide by the y. Step 2 is to use the tree map that I'm about to create with you. So here we go. We're going to create a tree map that has the 3 types of solutions. Notice I'm going sideways with mine, just so I can have a little more space. One, none, infinite. The key to the 1 is different slopes. If the lines have different slopes, they will cross. So if I had y equals 3x plus 4 and y equals 2x minus 1, as soon as I see different slopes, I know they're going to cross. None would be same slope, different, y-intercept. Same slope, different y-intercept. An example would be y equals 2x plus 3, y equals 2x plus 7. The same slope, but the different intercepts, they will not cross. Infinite would be same slope, same y-intercept. Pretty much, actually not pretty much, this means they're the exact same equation. So y equals 5x plus 6, y equals 5x plus 6. Same slope, same y-intercept. So let's keep those notes available as we start looking at some example problems. All right, I'm looking at this one, and what do I see? I see I see that they have the same slope, and they have the same y-intercept, and my notes say same slope, same y-intercept, infinite solutions. Let's look at this one. I have different slopes, right? Different slopes. What does that mean? Different slopes. One solution. Ooh, what are the slopes here? No, let's really make this very obvious what's going on. This is 1 over 1 plus 0. This is 1 over 1 plus 5. Same slope, different intercepts. Same slope, different intercepts. Same slope, different intercepts means there's no solution. Those lines are parallel. How about this one? Different slopes, one solution. Ooh, different slopes? Are they different? They're not different slopes, are they? They're the same slope. 0.5 is the same as a 1/2. So this is 1/2 x plus 6. This is 1/2 x plus 6. Same slope, same intercept. Same slope, same intercept, infinite solutions. What's going on here? Different slopes, one solution. Uh-oh. Remember, if I get something like this, I have to do a move the x, divide by the y before I get crazy with it. Move the x. Divide by the y. So y equals and then you have to simplify. And this would be what, like 1.2. Remember, in our notes, I told you step 1, do move the x, divide by the y if needed, and then use my tree map. All right, so before we can do this, we've got to do a move the x, divide by the y, and then we'll figure out what's going on. Move the x. Divide by the y. Then you have to simplify. Move the x. Divide by the y. Then you have to simplify. I have the same slope, but I have different intercepts. Same slope, different intercept. What does that mean? Going to the tree. Same slope, different intercepts. No solution. All right. Move the x. Divide by the y. Move the x. Divide by the y. Oh, y equals x minus 4, y equals x minus 4. This is the exact same line, which means it's infinite slopes. It's the exact same line. Move the x. divide by the y. Then you have to simplify. Move the x. Divide by the y. Then you have to simplify. Different slopes. Different slopes means, what does different slopes mean? Different slopes means there's one solution. Oh, you know what? This one, I'm not even going to do a move the x divided by the y because I can tell it's the exact same equation twice, which means infinite solutions. All right, we're going to stop right there. Because you can do this. All right, hey, thank you for watching and have a good day.